Welcome back, Pre-Calc. We're going to finish up with 7.4 and just going to quickly show you how you can use a graphing calculator to, prepare you for if you wanted to use statistics and a graphing calculator to be able to check some of your answers. So just real quick, in this problem we have an experiment that there's 2,500 bacteria in a culture dish at the beginning of the day, or anyway, we're assuming that at time 0 there's 2,500 in this culture dish. So after the end of each day, we can see at day 1, 2157, day 2, 1802, so on and so forth. And just before going to the calculator though, we should be able to answer that this is exponential decay. Because as you look at from one number to the next, we are decreasing, and that's sort of, I guess, the whole premise of exponential growth versus decay is that we are, if we are decreasing in bacteria, or in any situation, but if we're decreasing it, that's what's making this a exponential decay problem. So decreasing, decay. So I could walk you through a problem just like this if we were doing a problem where maybe this was no calculator and we can come up with an answer just like the first part of the video. Otherwise, what I want to show you is that you can actually create in stat, you can edit your list, and try your best not to delete a list because it will go away. And there was ways to bring them back. So if you have an issue with your list, you might want to just bring your question to class or email me. So I'm going to start with 0, 1, 2, 3, 4, 5. So if you already have a list in there, we're going down to 6. What you might need to do is just go to the top, I believe it is, and hit the clear button, not delete. And so it didn't go away, but if you hit delete, it will go away. So try your best not to do that. So I'm just typing in the numbers as they match up. So if you already took down the notes on what to do next, you can probably know what to do next. But what you want to make sure you do is you quit out of the screen. So hit second mode to get out of there. Otherwise, what will happen, if you don't quit out of that, the next step, what they'll try to do is put it into the list, which is really weird. So anyway, we're going to go to stat. We're going to calculate now. And you may have done this before with a linear regression. But what we want is an exponential regression line. So as I hit enter on this, now it'll tell me what's your X list, which is list 1, what's your Y list, which was list 2. If you ever want to change that, what you can do, you have two options. You can either hit second stat, or you can hit second, and your options are 1, 2, 3, 4, 5, 6, if you ever have to change your list around. So like if I hit second stat, I can grab a different list, which I don't want to do. I'll just go ahead and hit enter on list 2 just to make sure. I'm going to hit clear on this because I don't want a frequency on this problem. Now this store regression equation is asking you if you want the equation saved in your calculator. Well, you can do that by hitting alpha trace, and you can store that equation into Y1. And now when I hit calculate, instead of me having to remember this equation, and it's not a big deal if you have an R squared or R value. I can show you how to put that on if anybody's interested. But you don't need it in this problem. It's showing you how closely your data points are to that. If anybody's curious how to get that on there, it's called diagnostic on, and you find it by hitting second 0. And if you go down until you get to the D's, you just have to turn your diagnostic on if it doesn't show up already. So you'd have to hit enter a couple times here, and now it's done, and you'd have to go back and redo it. But what I did is I saved that into y equals, so now I don't need to go back and figure out what that equation is. And remember, we like to round to 3 decimal places, so 2629.226 times 0.838 to the x power. And what I can do as well is I can go to my window now. I can go to my graph and see it, but in order to see it, I have to make my window go all the way up to, I'll just make my window go from 2,000 to, I don't know, 10,000. I'll count by thousands to be able to see that graph. Oh, I guess I forgot it's going to be decay, so that was a silly mistake of mine. I should be going from 0 to 3,000. I'll count by hundreds instead. So I forgot it was exponential decay. So that's what we want. If anybody's curious, your calculator does put the scatter plot on your graph, and that's under second y equals. And you can make a hit enter, turn the graph on, and this is again where you want to make your x list and your y list. If I hit second stat, and I can grab list 2. Yeah. So if I hit the graph now, you can actually see how the data points match up. Now, if you do that, you might want to go back to second y equals and turn off your stat plot, because if your data points don't fit inside, you'll get errors every time you go to your graph. So just kind of a word to you there, that your graphing calculator is a very complex machine, and if it's confused, it'll just say error. It won't fix it for you. So that's your step-by-step process. I'll go ahead and show you the answers here shortly, but now you can use your calculator, and you can see about how many bacteria would be present after 10 days. Well, if you're using your calculator, you can just hit second table. Whoops, I forgot I changed my settings on my table, so I need to change my settings back to count by ones. Whoops. There we go. If you hit second window, this is how you can change your table settings. So now if I hit second graph, now I can actually see when x is 10, I should have about 450 bacteria. Don't round the bacteria because they're kind of like human. You can't have 0.892 of a bacteria. That doesn't really make any sense. So you can get the answer that way. And then on what day of the experiment would the pharmacologist expect the number of bacteria in the culture dish to be below 100? Again, I would just go to my graphing calculator since I did this and just keep going down until I get to below 100. So it would be day 19. Another way you could do this is to go into y equals and make a second equation that says y equals 100. And you just have to change your window then to go up to 20, because as I showed you in the table, the answer is about 19. And now if I go to my graph, you can see where they cross each other is all the way over here. You can find your point of intersection by doing second trace. The fifth option is point of intersection, and hit enter 3 times over here. So about 18.5, but because it says after, I would go ahead and round that up to 19. And the last question, will the bacteria ever be completely gone from the culture dish? That answer should be no. And a quick reason for that is just talking about how exponential decay never really, because we have a horizontal asymptote, it never actually fully goes away. And goes back to that horizontal asymptote argument that we've talked about. So, as you can see, this guy does round to 3 decimals. A lot of math teachers will do that, but just so you know, bacteria, you should just go ahead and say 449. I think I said it was 450, but that's because I used a different feature of the calculator to get a better answer. Again, I interpreted this problem to be the day after, on what day. So I would round this up to 19, but again, a good habit, oh, he sets it right here, is to practice rounding to 3 decimals. And again, we have a horizontal asymptote at y equals 0. So the number of bacteria will never actually get to 0. So it will never be completely gone. So kind of an interesting argument there. Yeah, so that's how we can use technology to help you understand. And just so you're aware, the homework for 7.4 are a couple free response questions. And yes, the answer keys are already in there. I still want you to do these and submit them, but you should be able to check your work before you turn them in. And then I'll see you again for section 5.